Greetings, ladies and gentlemen. This is Mr. Blynn, New York City math teacher and virtual content specialist with Unit 8, Probability and Sampling, Video 1 of 2. Day 1, Mystery Bags. How can the results of a previous experiment help us to predict the likelihood of a future event? Now let's go to slide A. And what I've done, and I will share this with your teacher, is created a Jamboard for this slide. That way it's a little easier to show your work. Introduction, slide A. The learning target in math language is the following. I can get an idea of the likelihood that an event will occur based on the results of a previous experiment. In regular everyday language, that's I can see if I can predict the future. That's the likelihood an event will occur in the future based on what happened in the past, based on the results of a previous, which means the past, experiment. To answer this, let's use Polya's 4-step method, which is understand, plan, solve, and check. But actually, it's 5 steps. And we can also use this for reciprocal teaching. Reciprocal teaching is where students teach each other. There's a moderator that will ask each question. What do we know? What do we want to know? Clarify anything you don't understand. Plan, how will we solve the problem? Solve, and check. Is our answer reasonable? Explain. Reciprocal teaching in student groups, there will be a student moderator that will ask the question. And then each student, including the moderator, will take a turn answering these questions. This is a great way to, first of all, analyze a problem to solve it the way Polya did, and also to facilitate really great discussions in student groups. So let's do that. We're going to understand, clarify, plan, solve, and check. Students, if you are using reciprocal teaching, remember at the beginning to read the problem. Then each student takes a turn answering these questions. Then once you've clarified everything, reread what you know and what you want to know. Then plan, solve, and check. Let's do this together as an example. Let's read first. Andre and his dad have been fishing for 2 hours. In that time, they caught 9 bluegills and 1 yellow perch. Next time Andre gets a bite, there's a fish on the line. What kind of fish do you think it will be? Explain your reasoning. Well, what do we know? We know that his dad had been fishing for 2 hours. And in that time, they caught 9 bluegills and 1 yellow perch. For shorthand, we can write K, for this is what we know. What do we want to know? Let's put a W there for that. The next time Andre gets a bite, what kind of fish do you think it will be? And explain your reasoning. Well, we did a little bit of clarifying up here. A previous experiment is something that happened in the past. But you may have other questions like what's a bluegill or what's a yellow perch? You can certainly ask each other and also Google search anything you don't know to clarify. So we've got that. So far we asked what do we know? What do we want to know? We've clarified. Now it's time to reread this understand section. Well, they've been fishing for 2 hours. They've got 9 bluegills and 1 yellow perch. And the next time he gets a bite from a fish, what type of fish do you think it will be? Explain your reasoning. Next part is plan. How will we solve this problem? One great way of solving all these type of problems is, and that's the plan I recommend for this problem, is make a drawing. Making drawings in math is very useful. It's good to visualize. Get a picture of what's really going on in this situation. What I've done here is I've made some drawings already. You can make a drawing in any other program. You can make a drawing here. You can draw a fish, for example. And then you can simply take a screenshot and add it to the slide by clicking on this icon here. And you can add a screenshot of anything from the internet as well. You can do a Google image search for fish like this and insert that. These are things that you can do when you're in a Jamboard to help you make drawings. And the good thing with making a drawing by taking a screenshot and adding an image is that you can always duplicate that drawing. You can make many copies. It makes it much easier than drawing it over and over again. Of course, you can undo all these things. So we have our drawings. Now what do we do with them? Well, let's make a drawing that represents this problem. So here we go. We have now 9 bluegills. So we can make that 9 bluegills. So we've got 9 bluegills. We can organize them in groups. And we've got 1 yellow perch. That's what we caught. That's what Andre and his dad caught. So they caught this fish. This is what we call a sample. This is not all the fish that are under the water. This is just a sample. This is what they've pulled out of the water so far. They're asking, what do you think the next fish? Do you think it's going to be a blue fish or a yellow perch? So here's the water. Underneath this water, what do you think is under there? Based on the sample or the group that we've pulled out of the water, what is under that water? What do you think is likely under this water based on the sample that they've taken out of the water? Do you think it's mostly blue fish still under the water and a few yellow? Do you think maybe it's half and half? Or do you think perhaps there's tons of yellow fish under there? There's also lots of different possibilities that I didn't mention. What do you think? Based on this sample of what they caught so far, next time Andre gets a bite from a fish, will it be a blue fish or a yellow fish? And explain your reasoning. Pause the recording here, write your answer here, then press play to continue.